Hello, good morning. How are you doing? And welcome back to my channel. And this is for the love of chemistry. Here we make chemistry simple, easy, exciting, very exciting and sweet. Okay, so today I want to continue what I started earlier. I paused a bit so that I can tell you how to do a titration table because since we don't have things for practical here, so I'm kind of teaching you how to report your practicals. So I digressed a bit to teach you how to write your table in accordance to your teacher's endpoint. So today I want to continue what I started earlier. I was discussing the uses of titrations. So one of the uses was standardization of a solution. We did that, we used equation to show how titration helps to standardize a solution. So now we are going to continue with the uses, and we're not just doing the uses and just we do the uses and then it's like, no, we are doing the uses in respect to questions. So for instance, look at the question we have on the board, and this is determination of relative molar mass, or you can call it relative molecular mass. So what are we doing basically? We are using the knowledge we have of titration to determine certain things, like how we do our titrations, then from there we can deduce what we don't know earlier. So we did the first one, standardization. If you've not watched the video, please go back and watch the video. This is the second use, and we're using the equation to show what we are doing. So we have a question here. It says A contains 1.60 grams of triazonitrate 5 acid in 250 cm cube of solution. B contains 10.0 gram per dm cube of X hydrogen triazocarbonate 4. Then the question says 25 cm cube portions of B required an average of 24.90 cm cube of A for complete neutralization. Calculate A, concentration of acid in A in mole per dm cube. Then concentration of this compound X, we don't know the formula for X. We are supposed to find out from solving the equation. So X hydrogen triazocarbonate 4 in B, a mole per dm cube. So this is a question that will help us to determine the relative molecular mass of this particular compound that we don't know the element, because I didn't even know what element X is. It's very easy to calculate the relative molecular mass. You don't need titration. But because we don't know it, we will use knowledge of titration to do this. Already the titration has been done. That is why here 25 cm cube of B was neutralized by 24.90 cm cube of A. So this came from titration. That is how we are able to get it. We get that from titration. So the question now says the concentration of acid in A in mole per dm cube. So that is what we are going to look at right now. And I want you to do something. The first thing you should do whenever you have a chemistry question is to read in between the lines. Don't just read without taking note of everything you see. So let's do that reading again. Reading in between the lines. A, excuse me. A contains A. You want to see the parameters that has to do with A. Contains 1.60 grams. So A has 1.60 grams of triazonitrate 5 acid in 250 cm cube of solution. Take note of what they said. They said it's not in 1000 cm cube. It's in 250 cm cube. So this is in 250 cm cubed. Now let's look at that statements. If you remember or recall our definition of mass concentration, it is the mass of a substance in 1 dm cube of solution. The mass of a substance in 1 dm cube of solution. So if I look at this and I'm asked to get the concentration of A in mole per dm cube, and if I assume that this is my concentration in gram per dm cube, I am wrong. Why? Because this is in 250, not 1000. And remember, 1 dm cube is equal to 1000 cm cube. So had it been that we are told that A contains 1.6 gram of triazole acid in 1000 cm cube, that would have been our mass concentration. But because it did not tell us it's in 1000 cm cube, but it's in 250 cm cube, then that is not our mass concentration. For us to get our mass concentration, which when we get it, we can now use it to get our molar concentration, we will have to find out the quantity of A in 1000 cm cube. And we can do that using what we already given. So if A contains 1.60 gram of triazole acid in 250 cm cube, then how much of A will be in 1000 cm cube? That is what we are looking for right now. But you have to make a statement of fact and write your formula, because all these things have maths. I'm trying to get your mind to understand why we are trying to get the one for 1000. We have been given the one for 250. 250 is not our ideal concentration, because our ideal concentration for mass concentration is the amount in 1000 cm cube, or the amount in 1 dm cube, and 1 dm cube equals 1000 cm cube. So if this were to be 1000, remember I said that would have been our mass con, but because it's not in 1000, it is what we will use to get our mass con. So that means before we can find the molar con, which is mole per dm cube, please, if you are not conversant with the terms I'm using, I've already explained this in earlier videos, so do well to go there to get there. So if we are asked to get our concentration in mole per dm cube, then we will need certain parameters. So let's do it this way. Question A says the concentration of acid in A in mole per dm cube. So mole per dm cube is molar concentration will be equals to mass conc all over the molar mass. The mass concentration all over the molar mass. But we are not given the mass concentration, and we can find the molar mass because we know the elements that make up the compound, so we can very easily find the molar mass. The only thing that we are yet to have here is the mass concentration, but we are given something via which we can be able to get a mass concentration. So let's do this. So we have, now we can bring down this, because I was trying to use this to explain it. We can bring this down here and state that 1.60 gram of triazole acid contains 250 cm cube. Then to get mass conc, to get our mass conc, 1.60 grams is in 250 cm cube. So 1000 cm cube will contain how many? We'll cross multiply. We'll cross multiply. We have that 250x is equals to 1.60 times 1000. So our x will be 1.60 times 1000 all over 250. And that will give us, this here will give us 4. 4 times is 4 times 0 is 0, 4 times is 24, right? 4, 2, 4 times is 6 grams per dm cubed, because we just found the mass conc. You can't jump any step because this has its own mark. You must follow the steps. So we have found the mass conc, and remember the unit of mass conc is in gram per dm cube. What it's saying is that this is the amount you will see in 1 dm cube, and 1 dm cube is equivalent to 1000 cm cube. But we've not solved the question. Now recall our initial formula, which says molar conc is equals to mass conc over molar mass. That means we have gotten the first thing here. We need to get the second one. So I don't want to clean up the other question. So to get our molar mass, remember everything that you are supposed to solve has its own mark. So you don't solve it in your head. You will not go to your head and mark it. So you have to solve it here. So molar mass of trialdehyde acid what is the mass of hydrogen? 1 plus mass of nitrogen 14 plus mass of oxygen 16, but there are 3 atoms of oxygen, so 16 times 3. So when you add up, this guy just will give us 48 plus 14 plus 1, which is equal to this plus this is 15. When you add 15 here, that's 63 gram per mole. Please note that whatever you are doing, make sure that you put your unit. Make sure that your units are correct. Gram per mole. Every mole of this contains this gram. So gram per mole. Now we have all our parameters. Now we can now fix them to get our molar conc. Alright, so let me use this little space here. So our molar conc, which is mass conc over molar mass. What is our mass conc? 6.40 gram per dm cube. So 6.40 is, so that you don't, molar conc, you don't need to repeat the formula, you've already written it, equals to 6.40 all over 63. So when you divide this, you have 0.102 mole per dm cubed. I hope that's very clear. That's very clear. So let's look at the second question. Concentration of X hydrogen trialdehyde 4 in B a mole per dm cubed. Alright, so when we look at this, we are looking for molar conc again. And from our question, we see we've already solved the first one. So from the first one, we have the concentration of A in mole per dm cubed. From the question, we have all the volumes. We have all the volumes. So from the, and please, because my board is quite small, I was unable to put in all the questions. But at the end of the question, there is the equation for the reaction. They needed to give it because we don't know what X is. And even X was stated, you can be able to write your own balanced chemical equation. So we are given the balanced chemical equation first. So let me continue. So we are looking for concentration of this in mole per dm cube. Okay. Now, from all we are given, if we look at this formula,